This video is on a technique of solving quadratic equations called the quadratic formula. The quadratic formula always works. The details can sometimes trip students up. You've got to watch your signs, you've got to watch your parentheses, you've got to use your calculator very carefully. But the quadratic formula will always work. There's an initial requirement, just like with factoring. The quadratic equation must have all terms on the same side and be equal to 0. The only way to identify A, B, and C accurately is if all the terms of the quadratic are on the same side of the equation and there's an equal 0. This is called standard or general form of the quadratic equation. The quadratic formula tells us that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now notice b, the b right here, that's the coefficient on x. There's b again here, that's squared under the square root. There's a 4, that's just part of the formula. A is the leading coefficient on x squared. C is the constant term, which is the number that has no variable. The 2 is magically just part of the formula, and A, again on the bottom, is that leading coefficient. So let's apply this to some examples. Our first example is solve 6x squared minus 7x minus 3 equals 0. Because all the terms are on the same side and we already have the equal 0, we can identify A, B, and C immediately. Notice the sign in front of the term belongs to the term. So A is positive 6, B is negative 7, and C is negative 3. X equals negative B, which is negative 7, plus or minus the square root of parentheses negative 7 close parentheses squared minus 4 times A, which is 6, times negative 3. That's C. This is all over. Notice that my fraction bar begins here and ends over here, divided by 2 times A, and A is 6. All right, so that's pretty ugly, but if you're careful, it will give you the right answer guaranteed. So negative 7, the opposite of negative 7 is positive 7, plus or minus the square root. Negative 7 quantity squared is positive 49. Negative 4 times 6 times negative 3 is positive 72. This is all over 2 times 6, which is 12. This is equal to 7 plus or minus the square root of 49 plus 72, which is 121, all divided by 12. Now you can try to take the square root of 121 and see what happens. You might be surprised to find that it is a perfect square. The square root of 121 is 11, all over 12. When that happens, when your radicand, which is the number under the radical, is a perfect square, it means that you could have factored the original problem. But it's okay that you didn't, because we can still find the answers. Now there are two answers here, so let me kind of split these up. 7 plus 11 divided by 12, and 7 minus 11 divided by 12. 7 plus 11 is 18, divided by 12. 18 twelfths reduces to 3 halves. 7 minus 11 is negative 4 over 12. Negative 4 twelfths reduces to negative 1/3. And we have two rational number answers, 3 halves and negative 1/3, which indicates, because they're kind of pretty, so to speak, that we could have factored the original problem. But it's okay that we didn't, because we found the answers. All right, next. Our next example is solve 4x squared minus x minus 6 equals 0. We have the equals 0 already, so we can go ahead and identify A, B, and C. I'm going to write these out because B is negative invisible 1, and C is negative 6. So we have, using quadratic formula, x equals negative negative 1 plus or minus the square root parenthesis negative 1 squared minus 4 times A, which is 4, times C, which is negative 6, all over 2 times 4. Now remember, the 4 right here comes with the formula. This 4 right here is A, and this negative 6 is C. The 2 on the bottom comes with the formula, and the 4, of course, is A. So now we have negative negative 1. The opposite of negative 1 is positive 1, plus or minus. Negative 1 quantity squared is positive 1. Negative 4 times negative 6 is positive 96, all over 2 times 4, which is 8. And this is equal to 1 plus or minus root 97 all over 8. I said 97, I wrote 96. Okay, 97. Now, you can try taking the square root of 97 on your calculator, and you'll quickly find out that it is not a perfect square. So our two solutions are x equal 1 plus root 97 over 8, and x equal 1 minus root 97 over 8. Now we can't make those any prettier than that. Those are the perfect, exact solutions. Now, in the real world, the mathematician's job is to find the exact solutions. It's somebody else's job to decide how accurately they want the answers. But we can go ahead and type these into the calculator carefully and find that this first answer is approximately 1.356 to 3 decimal places, and we can find that the second answer is approximately negative 1.106. But exact answers are preferred. So the preferred solutions, ugly as they may be, are those. By the way, the fact that these answers are so ugly, they're not rational, let's write that down. Not rational. These are called irrational numbers. Means that we could not have factored the original quadratic, even if we tried. All right. I should say we couldn't have factored it using only rational numbers. Next example. Solve 3x squared plus 7x equals negative 2. Now remember, before we can identify A, B, and C, we have to have all our terms on the same side of the equation, which means I need to add 2 to both sides. So I get 3x squared plus 7x plus 2 equals negative 2 plus 2 is 0. Notice you can't combine 7x and 2 because they're not like terms. All right, so A is 3, B is 7, and C is 2. Quadratic formula tells us that x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, and this is all divided by 2 times a. This is equal to negative 7 plus or minus the square root of 7 squared is 49. Negative 4 times 3 times 2 is negative 24. All over 2 times 3 is 6. And this is equal to negative 7 plus or minus the square root of 25. 25 all over 6. Now try taking the square root of 25 and, well, it's 5. 25 is a perfect square, so we have negative 7 plus or minus 5 all over 6. And then we get two solutions, negative 7 plus 5 over 6, negative 7 minus 5 over 6. Negative 7 plus 5 is negative 2. Negative 2 over 6 is negative 1/3. Negative 7 minus 5 is negative 12. Negative 12 over 6 is negative 2. We've got rational number answers again. These are rational fractions, rational, which means we could have factored the original problem, but it's okay that we didn't. We found our solutions and we found them correctly. Okay, so those are the solutions to this quadratic equation. All right, next example. 4x, so we're solving 4x equals 2x squared minus 3. Notice once again that we have terms on both sides, non-zero terms on both sides, so we need to gather those to one side. I'm going to take the fast way and subtract 4x from both sides. That leaves 0 on the left, 2x squared. I'm going to go ahead and put my minus 4x in the middle where he belongs, minus 3 on the end. And now that I have my equals 0, I can identify A, B, and C. Quadratic formula tells us that the solutions are equal to negative b, which is negative negative 4, plus or minus the square root of negative b, quantity squared, minus 4 times a, which is 2, times c, which is negative 3, and this is all divided by 2 times the a value 2. This equals negative negative 4 is positive 4, plus or minus the square root. Negative 4 quantity squared is positive 16, plus 24 all over 4. And this is equal to 4 plus or minus root 40 all over 4. Now these are the right answers, but there's some simplification that can be done, and you may or may not have any experience with this technique. 40 can be factored into 4 times 10. Of course, 40 can be factored into 8 times 5, 20 times 2. The reason I chose 4 times 10 is because 4 is a perfect square. So I can take the square root of 4, which is 2, and pull it out of the radical and put the 2 in the front of the radical. and then leave the root 10 behind. So that's called, what is that called? Simplifying the radical. Now there's one more bit of simplification. The numerator has a common factor. It's two terms, and those two terms have a common factor of 2. The denominator also is divisible by 2, which means we can simplify this. Now I call this the V for victory. When you have two terms on top and only one term on the bottom, and those terms have a common factor, you can divide each of the terms by that common factor. So I'll do it mentally, but this is what it would look like if you wrote it down. You're dividing each one of those by 2. And you get 4 divided by 2, which is 2, plus or minus. 2 divided by 2 is 1. Root 10 stays there. 4 divided by 2 in the denominator is 2. And this expression represents your two solutions. The two solutions are x equal to plus root 10 all over 2 and x equal to minus root 10 all over 2. One more comment about the simplification I just did. You can't divide 2 out of 10 because there isn't a factor of 2 in root 10. Okay, so the root sort of protects it from the simplification. These are the exact value answers. Mathematicians should always give exact value answers. If you plug them into your calculator, just to give you an idea of how big they are, you get 2.58 and you get negative 0.58, 2 decimal place approximations. We have one more example, and it's special because it has a problem for the Algebra 1 students. So let's find out what that is. Solve 5x squared plus 2x plus 7 equals 0. Now notice we have the equal 0, so we can identify a, b, and c right away. Quadratic formula tells us that x equals negative b, which is negative 2, plus or minus the square root of b squared minus 4 times a, which is 5, times c, which is 7, all divided by 2 times the a. And that's equal to negative 2 plus or minus the square root. 2 squared is 4, and then negative 4 times 5 times 7 is negative 140, all divided by 10. This is equal to negative 2 plus or minus the square root of negative 136, all over 10. The radicand, negative 136, is negative. So its square root is not a real number. So the square root of negative 136 is non-real. And this creates a problem. So this basically means this particular equation doesn't have any real solutions. And in Algebra 1, the answer to the question is no real solutions. You'll learn a more interesting and more precise way to answer this question in Algebra 2. So here our answer is no real solutions. Okay, remember when you solve using quadratic formula, you have to get all your non-zero terms on one side of the equation so that the equation is equal to 0 before you identify a, b, and c. And as always, the sign in front of a term belongs to the term, so watch your negatives. Thank you for watching.